Hey buddies, my name is Sibusiso, but you can also call me Coach Sibu. Welcome into the Maths Buddies tutorials. In this video, we're going to be covering the fourth topic of the March exam preparations, and that is the grade 12 Euclidean geometry. Now, specifically, this video is going to be mainly focusing on similarity, and also I'm going to be sharing with you some of the methods and tools and skills that can help you ease the work or the pain that similarity actually gives a lot of people, because it is a struggle for people to answer questions that have to do with similarity, right? So also please don't forget to share this with your friends so that they can basically get this valuable information. So without wasting any further time, we're gonna jump straight into the video. So the video is gonna be mainly grade 12, focusing mainly on the similarity. So before I can even go into the question, it's very important to understand something about similarities, right? So in similarities, the reason why it is so painful to other people, right? The reason for that is because similarity is a combination of two things, right? So they've combined the grade 11 Euclidean geometry, that is when we're calculating angles and all of that, and then they have a combination of that with the proportionality theorem that you learned in grade 12, where you're talking about ratios and all of that. So it means now, the reason now it becomes so painful is because now it seems like it's something that is on its own, but it is not, right? It is just that in order for you to understand the similarity questions, you need to dissect it based on those two things. Firstly, the angles, and then secondly, the proportionality. So in this video, I'm basically going to be showing you how to do all of that, right? So let's go ahead and read the instruction, and then from there, and then I'm going to be explaining as we go into each step, right? So let's go ahead and read the question 7. It is read as follows, right? It says here in the diagram below, AB is the diameter of a circle with center O. SK is a tangent to a circle at C. OS is perpendicular to AB. CA and OS intersect at T. Then KOBA is a straight line, and then let A to be equals to X. So now here, as you can see, when you're looking at this question, right? Because of now we know it is a grade 12 and it's a similarity, right? The first thing that you always need to do is to look at a diagram. So when you look at this diagram, you cannot see which angles or which triangles are similar here, but you can see that now here I can actually apply theorems, right? So this means now the very first thing that you always need to do when you have such diagrams, it is to, number one, find the angles, right? Because that's the very first thing that you need to do about similarity. Now, how do you find angles? Remember, when you find angles in grade 12, in grade 11, you use what we call DRCPT, right? There's a video that I've uploaded on the grade 11 Euclidean geometry. Please make sure that you watch that so that you can get an understanding of how this thing works, right? So basically, the D stands for radius. D stands for diameter, R for radius, C for cyclic quad, P for parallel lines, and then T for tangents, right? So now here we're going to start with D. So D, if you remember, it was mentioned that we have a diameter there. So we are going to start with the diameter. So when you see a diameter, what theorem comes to your mind, right? So the theorem that comes to my mind, it is the angles on the semicircle. So which means now here you need to find those angles. So angles in a semicircle, here I can see that it is C2 plus C3. These two angles, when I add them, it is 90. Now, as I'm going through these angles now, I'm going to keep explaining to you other things, right? Here basically notice that I didn't say BCA, right? I said C2 plus C3. Very important to do that when you're dealing with Euclidean geometry, because BCA, if this angle BCA wasn't a line that was cutting it into two parts, it was going to be okay writing it as BCA. But then now writing it as C2 and C3, it means now you are aware that C2 is alone and C3 is alone, but then combined they just form BCA. All right. So first part it is that, so which means we are done with the first part. Then now the second part is going to be the radius. So when you talk about the radius, what are the things that should come to your mind? So when you see the word radius, right, or if you hear that you have a radius, how do I know that I have a radius here? It's because remember we were told that we had a center. So any line from a center that touches the circle and doesn't pass it is called a radius. For example, here OB is a radius, OC is a radius, and OA is a radius. All right. So now, what comes to my mind, or what comes to your mind, or what should come to your mind when you see the word radius? So, thing that should come to your mind, right? This is the theorem that says angle at center is 2 times angle at circumference. All right. So angle at center, how do you identify angle at center? Angle at center is an angle that is formed by 2 radius, right? So, or radii. So for example, here we can see that O1 plus O2 is an angle formed by the radii OC and OA. And then that is the arc that they formed there. So the angle at center, it is twice the angle at the circumference, which is B1. So here, first thing that I see then, it is O1 plus O2, right? It is 2 times B1. That's the first part. Okay, so what's the, do I have another angle at center here? Yes, I do. OC and OB, they formed O3. So O3 is the angle at center, right? So I know that the angle at circumference is going to be that one, right? So it's going to be something like this, right? Angle at center is twice angle the circumference. So O3, it is going to be 2A. Okay. Now, what's the next thing that you need to think of when you see radius? Next thing that you need to think of when you see radius, it is the isosceles triangle, right? Isosceles triangle. Why isosceles triangle? Because remember, if you have 2 radii and then there's going to be a chord that forms those 2 radii making a triangle, it means those angles are going to be equal. Why? Because the sides are equal, right? So that's basically what is happening when it comes to this one, right? So here we can see that we have triangle. Firstly, I'm going to start with the first one. So I'm going to write it as A. So triangle OCA, right? So what can I take on triangle OCA? I can see that C3 is the same as angle A, right? And then secondly, triangle OBC, I can see that C2, right? C2 is the same as angle B1, right? Now the question is this, are they all equal? And the answer is yes, they are all equal. C3 is the same as angle A, and it is also the same as C2, and also the same as B1. Why? Because these are radii, right? So radii there and radii there. So the triangles, these lines, by just joining these lines like that, it means all of these angles are the same, right? So this just means that you don't have to put that, you can just put it, or you just need to be aware of it. But this is the most important thing, just to actually separate them. I like to separate them like that because when I look at it like that, it means now I'm just going to be doing everything that is black one at a time. All right, so cyclic quad. So the next part of the cyclic quad, we don't have a cyclic quad here, and then we also don't have parallel lines, but we were told that we have a tangent. So I'm going to tick that. So the tangent, let's see, I'm going to write tangent. So what do I have about the tangent? So the very first thing that I think of when you see the word tangent, it is the radius perpendicular to the tangent. So now here, radius perpendicular to the tangent. All right, so which radius is that I'm talking about? I'm talking about OS. So OS is perpendicular to KS, or SK is my tangent. So this means now here C1 plus C2 is 90, right? And also C3 plus C4 is also 90. All right, now what's the next one after that? Next one that I see there, it is the 10 chord. So number 5, it is the 10 chord. So what is happening on the 10 chord? I see that here I'm looking at triangle CBA. Remember, 10 chord, you need to have a tangent, and then from that tangent you need to form the triangle starting from where the triangles touched the tangent. So you can go whichever direction that you want to go there, but the idea is that once you form that triangle, its corners must touch a circle, and then this angle is going to be equal to that, and that angle is going to be equal to that one. So that's basically what we're going to be doing here, right? So the 10 coordinate, since it's just one, I'm just going to leave it as C4 is equal to B1, right? And also C1 is equal to A. Okay, is equal to A, like that. Okay, so now we have found all the angles. So now here, because we have found all the angles based on the Dr. Cape Town, it then means that we need to ask ourselves, was there any extra information that we were given there? And yes, there was. We were told that OS is perpendicular to AB. So which means now the extra information, we need to write that down, right? So we were told here that OS is perpendicular to AB. So what does that mean? Remember, we're not talking about sides here, we're talking about angles, right? The heading we said we find in the angles, which is the very first thing that you need to talk about when you're dealing with similarity. So we're finding the angles here. So it means here we see that OS is perpendicular to AB, but what does that mean when it comes to angles? So here's OS perpendicular to AB, right? So it means O1 is 90 and O2 plus O3 is 90. So which means now I'm going to say O1 is 90, right? And then O2 plus O3 is 90. All right. So was there anything else that we given there? Yes, there was. We were told that A1, sorry, let A to be X, right? So they said here angle A is X. So what does this mean? So it means here I'm just gonna look for where my A is and then just equate that with X. So this is X, there's A there, so I'm just gonna write it as 2X, there's A there, and that is also X, right? Then now in my diagram, I'm just gonna put in X there so that I know that this is what I was given, right? So now let's go ahead and look into the question. Now, here's the thing, before we can even go to the question, right? After you find the angles, right? The second thing that you're supposed to do is you need to find the proportionalities, right? So now here the proportionalities, it is the part that is included grade 12. Now the only way you can find those is if they are parallel lines, right? Now here in this diagram we're not given any parallel lines, so which means that we won't be thinking about that part, right? Remember, similarities are broken into two parts, angles and proportionality. So which means angles, it is going to be your theorems that you've covered in grade 11, and then proportionality is going to be the one that's saying line drawn parallel to the third side of triangle divides the other two sides proportionally, which is the grade 12 proportionality, right? But then now here it requires you to have what? Parallel lines, of which you don't have them here. So which means we don't mind if we don't have them. We can just go to the question because it means the questions that are given there, they will only require these angles that we have found today. All right. So now let's go ahead and go into our very first question. So the very first question here, it says that we need to prove that KCT is equal to T2. All right. So now 7.1, I need to prove KCT is equals to T2. All right. So when I'm proving, understand this, when you're proving angles, right, always calculate the angles separately, right? What do I mean by this? I mean that if I'm proving KCT is equal to T2, I just need to ask myself, what is KCT when I'm calculating them separately, right? Then also I need to ask myself, what is T2 when I'm calculating them separately? Then from there, I'm just going to see if the answers are equal, right? But before we even get there, the first thing that you always need to do is you need to check where KCT is. So now here, we can see that KCT is that angle, right? Then now here, there's a problem here. What is the problem? The problem is that here, we are given KCT. But then remember I said earlier that when you're given an angle, there shouldn't be lines that are cutting those angles. For example, here, I can call this angle A, it's fine to call it angle A, right? But the minute I have lines like that, right? Like if I have a line crossing there, then I can no longer call this angle A. I can call it A1 plus A2 to show that these angles are separate, right? So the same is true here. They gave you KCT to confuse you, right? So it means now what you need to do is you need to realize that you're not proving KCT is equal T2 here, but you're proving C1 plus C2 plus C3 because that's what KCT has been broken into. So you're proving that this is equals to that, right? So now, how do we do that? So firstly, we're going to start with the part for C1 plus C2 plus C3 because remember we said we need to prove these things separately, right? So now here, what I'm going to do is I'm just going to go back into my instructions and see what was I given. So now here I'm just going to look for C1. If you remember, we said C1 was equals to angle A, which is X, right? So it means now here I do know that C1 is equals to X, right? So that's the first thing I'm going to say here. C1 is equals to angle A, which is X. And then the reason for that, it was the ten-chord theorem, right? Okay, so I know what is my C1. And then what about C2 and C3? If you remember earlier, we were told that C2 plus C3 is 90, right? So now, which means I'm going to say C2 plus C3, it is 90. And then this was angles on semicircle, right? So now, what does this mean? So basically, this means now C1 plus C2 plus C3, it is X plus 90, right? Or you can just write it as 90 plus X, right? So I found my C1 plus C2 plus C3 that it is 90 plus X. So I'm going to keep going back into this one here and then just going to be updating the angle there, the angles that are equals to X. So I'm just going to put X there, right? So then 90 plus x's, I don't want to write those because they're going to be confusing. Can I put this as 90? Yes, you can. I can put it as 90, but it's fine to just have it there and then just look at it. Okay, now this is 90, but if you want to write it there. I don't like to combine things, right? So hence I'm not going to write it as 90, but I know that it is 90. All right. So I have found C1 plus C2 plus C3. So now I need to calculate T2. So now I'm just going to go and check. Do I have T2 there? Let's see. All right. I do not have T2. So if you don't have T2, what does that mean? So basically, if you don't have T2, then this means that the angle T2, right, it is an angle that acts as either, number one, acts as an interior angle of a triangle that you have information of, right? Or a triangle that that you have an information about, right? Or secondly, it acts as an exterior, right? Of what? Of a triangle that you have information about. Okay. Now, for example, here, if I'm looking at T2, it means I'm looking at this angle, right? Now, as an interior, it means T2 is combined with C3 and O2. But then the question is this: do I know what C3 is? Remember, we were not told what C3 was, right? Oh yeah, C3 here, we told that it was X. So yes, we do have it. Let me see. I'm gonna tick that. Now, do I have O2? Let me see. O2, no, we do not have what O2 is, right? So because of that, it then means now this angle, I cannot use it or I cannot let it act like an interior, right? So now what about the exterior? As an exterior, it means it can be an exterior of C4 and S combined, or it can be an exterior of O1 and A combined, right? So now here's the thing. I'm going to ask myself, with C4 and S, do I have angle C4? No, but I can find C4 is B1, right? I can find that. But what about angle S? Angle S, I don't know what angle S is. So it means I'm not going to count that. What about the last part? So the last part here, I can see that angle A, I know it is X, and then I can know that O1, if you remember, we were told that O1 was what? It was 90 there. This is something that we were given. So it means basically I can then find my T2 because now I have both the angles there, right? I can find both. So this means now T2, I can calculate it and then say, number one, T2, it is the same as O1 plus A, right? The reason for this is because it is an exterior angle of triangle OTA. All right, so now this means I know what A is, right? It is X. So it's O1 plus X. Now the question is, what is O1? So going back, we said O1 was 90, and then we were given that. So therefore, I'm going to say O1, it is 90. I was given. right? What were we given? We're given that OS was perpendicular to AB, right? So because of that, it then means now T2 is equals to 90 plus X. Now, do you see now, after proving this, that these two angles are equal? They are both 90 plus X. So what does this mean? So this means now C1 plus C2 plus C3, which is known as KCT, is equals to T2. And that is how you get your answer, right? You see how easy that was? All right. So let's go ahead now and look into the second question. So the second question, 7.2, they say now we need to prove that triangle CKB is similar to triangle AKC, which is similar to triangle COT. All right. So now when you're proving that triangles are similar, what's the first thing that you must know? Firstly, you must understand that if you've given it like that, then it means you are given a hint there. So what is the hint? The hint there is that if you're given it as this order, right, they know that this angle C of CKB is equals to angle A of AKC is equals to angle C of COT. This K is equals to that K and that K, and then this B is equals to that C and equals to that T. But I just want you to actually show them, right? So now what are we going to do here to prove this? So the first thing that I'm going to do is you need to write this thing like in bold, right? So now this is what I'm going to do. We're trying to prove here triangle C. So now notice that I'm going to open up spaces here, and I want to explain why I'm opening up spaces. So we're trying to prove that triangle CKB, right, is similar to triangle AKC, which is similar to triangle COT. All right. Now, the reason why I'm opening spaces here is because if I want to prove that these are similar, I must know the actual angles of CKB, know the actual angles of AKC, and know the actual angles for COT. So what do I mean by actual angle? So this is basically what I mean. If you're looking at triangle CKB, so this is triangle CKB, right? You will notice here that the angle C there, it is not C. It is what? It is C1, right? The angle K there, it is K, right? But the angle B, it is B2, right? So the reason why I'm opening spaces is because I need to make sure that I'm focusing on C1, K, and B2, right? When I'm actually answering my questions. All right. So what about AKC? I'm going to do the same thing. Now look at AKC. So AKC, it is that big angle, sorry, big triangle there, right? So now here, what do you see here? You can see that angle A here is angle A, which is fine. And then the angle K, it is angle K, which is also fine. So what I'm going to do is, if it's fine, I'm just going to bring them closer because I know that they're just there. But then now with angle C, I can see just C1, C2, C3, right? So C1 plus C2, so I'm going to write it as 1 plus 2 plus 3, right? Okay, now what about COT? COT is this smaller than triangle D. So COT, C acts as C3, O acts as O2, T acts as T2. All right. Okay, so now this is basically what I need to prove here. I need to show that this triangle is similar to that and triangle is similar to that. All right. Now, when you're proving three triangles that are similar to one another, all you have to do is to prove that this is similar to that, right? And that is similar to that, right? Because if this is similar to that and that is similar to that, then automatically this will be similar to that, right? So you can use one of these three options, right, to prove. So it can either be CKB with AKC, right? And then secondly, it can be CKB with COT. That means they're all going to be similar. Or you can pick AKC with COT and then CKB with COT. That will mean all of them are similar. And then you can pick, or lastly, you can pick CKB with AKC and AKC with COT, and that will mean all of them will be similar, right? So now, one of those three options, right, you need to just pick two. So now, how do you then do this? So the very first thing that you always need to do is to always start with the triangles that are similar or that have a common angle. Now, how would you know that a triangle will have a common angle? So a triangle that will have a common angle will be a triangle will be a triangle that will be straightforward, right? So by straightforward, basically means now it will have the angle K. For example, here, I can see that K here, there was nothing added next to K and that K. So it means these two triangles, this angle K is a common angle between these two triangles. So it means now, therefore, the first thing that I'm going to do, right? The first two triangles I'm going to pick here, it is triangle CKB, right? And triangle AKC, right? So what am I trying to do here? I'm trying to prove that they are similar, right? So I'm going to prove if their angles are equal. Now, in order for me to do that, very simple. Only thing that I need to do is to prove that two angles are what? Are equal, right? If I find that two angles are equal of these two triangles, it means the third angle will automatically be equal. So now, let's go ahead and do that. So the first angle that I see here, it is K, right? So it means now I can see there that K is equals to K. Why? Because it is a common angle, right? Then now the second angle will then be me trying to see now if I have an information about C1 being equals to A, or B2 being equals to C1 plus C2 plus C3, right? So now here, well, I'm going to start with C1 equals to A. So do I have something that tells me in my instructions that C1 is equals to A? So I'm going to go back there and see. So going back there, yeah, right? I do have C1, yes, being equals to, let me just double see, yes, C1 being equals to A. It is something that I did prove in the previous question. There it was, C1 equals to A. So it means now here, I can say that C1 is equals to A, right? So where did I get this? This was proved in 7.1. So it means I'm going to write it as proven in 7.1. Now, because of I know that these two angles are equal, that means automatically B2 is going to be the same as C1 plus C2 plus C3. And then the reason for that, it will be the third angle. And then so this triangle CKB, it is similar to triangle AKC. What's the reason? Angle, angle, angle. So now here, what we're going to do after this is we're going to go into the next two triangles that we need to prove that they are similar. Now, to find the other two triangles that we need to prove that are similar, all we have to do now is to basically look at what we have. So far, we did this with that, right? So now what we're going to do is this. You're basically going to compare the first triangle with the third triangle, or the second triangle with the third triangle, right? Now the idea here is that you need to have two angles that you have information of, right, that are going to be equal, right? So because of I've already done this with that, right, normally we will then first test this with that, right? So now what I'm going to do is I'm going to test here. Okay, so I'm going to test from my instructions there, or from my information, do I have angle A being equals to angle C, right? Or do I see that, or did I prove that, right? So now angle A, I can see on my instruction that A is equals to C3, right? So what does this mean? So this means that I do have that. So A and C3, I have that. So what about K and O2? Okay, so I'm going to see if I have something that say K equals to O2 there. K, I don't have any K here, so it means K and O2, definitely not. Then now I'm going to look for the last one. C1 plus C2 plus C3 equals to T2. Remember, C1 plus C2 plus C3 is the same as your KCT. Then now here I can see that I did actually prove that KCT is equals to T2. That was on 7.1. So which means now this angle, I know that it is also the same as that. So because of that, it means now the second triangle that I need to prove that they are similar, it is going to be triangle AKC and triangle COT. Now, the only thing that I'm going to write here are those two things that I just did there. Angle A equals to C3. Then the reason for that is because of the base angles, right, of the isosceles triangle, right? Remember, OCA is an isosceles triangle, given that OC and OA are both radii. All right. So what's the next one? So another one, it is C1 plus C2 plus C3. C3 is equals to T2. This one was proven in 7.1, right? Therefore, because of that, it then means now angle K is the same as angle O2, and that is the third angle, right? And from there, we then say triangle AKC is similar to triangle COT, right? And then that was angle, angle, angle. Now, because of this, CKB is similar to AKC, and AKC is similar to COT, then this then means automatically CKB is also similar to COT. So it means now here, basically, we have proven everything, that all these three triangles are similar to one another, right? So I do not have to do the last part. I just need to prove that two are similar. It means automatically all of them are similar to one another. All right. Now the last one, it is 7.3. So 7.3, they say now we need to prove that BK times AK is equals to OT squared times CA squared over CT squared, right? Remember, we're proving here, right? Now, normally when we prove, right, we will firstly make sure that we get our similarities right here, right? So the first thing that you do when you're proving such questions, because these are the questions that become much more difficult to people to understand, because they don't give you a guide as to which one or where to start, right? So one thing that I will tell you for sure is that the easy way to approach this question, it is to basically start by writing what you have similar, right? So the triangles that are similar, we know that CKB is similar to AKC, which is similar to COT. Now, when you write the ratios here, it's very important how you write them. So now here, if I take this part, right, it means I will have to take that part or that part. That is, if I take two triangles, right? If I'm taking this part, it means I'll have to take this part or that part, right? And then if I'm focusing on the sides, because remember, we said that if they're equiangular, then they have the same ratio. And then here we can see that the question that wants us to prove is talking about sides, right? So this and that and that. All right. So now basically what I'm going to do here is I'm going to list all three, all right, ratios, but I'm going to do them separately so that you can have an understanding of what is happening here. So the first one that I'm going to take, it is CKB being similar to the first one and the second one. Let me just write it here. This is where CKB is similar to triangle AKC. Okay, so what can I get from these two triangles? So from these two triangles, I can see that if I have CK, if I take a ratio of CK over AK, right, this ratio, right, it is equals to, it is the same as KB, right, over KC, which is also the same as CB over AC, right? AC. Okay. Then now, second one will be triangle AKC being similar to triangle COT, right? So what can I take here? I can say here AK over CO is equals to KC over OT, which is equals to AC over CT. And then finally, the third one, I'm taking the first and the last one. So CKP similar to COT. All right. So what can we say here? we can then say here CK over CO is the same as KB over OT, which is the same as CB over CT. All right. Now, after I have this, what you're going to do here, it is you will then, because most of the time when you write this like that, most of the time you will notice that some of the letters here have been mixed up, right? So you'll notice that instead of having BK, you will have KB, right? So it means now the next thing that you do after you've listed all your similarities is just to make sure that you just fix all your sides and make sure that they're written in this order, right? Or if it is BK, it has to be BK everywhere. We shouldn't have KB. For example, here, I can see that for BK, I do have KB here. So I can fix that and write it as BK because it is the same thing. And then here, I also have KB there. So I'm going to write it as BK, right? It is the same thing, but it's just it is the order of the letters. BK, and then AK. Okay, I have AK there. AK there is fine. OT, I have OT there. OT, so OT is fine. CA, see here, I have AC, so which means I need to fix that as CA. And you see why I'm doing this, right? CA. I also have AC here, so I'm going to write it as CA. CA, and then CA out, CT. All right. So now everything here is in check. So now after having this, these are my similarities that I have. So what I'm going to do here is I'm going to ask myself, because now I need to prove that this is equal to that, right? And I can see that I don't have any possible way that I can do with this, right? So now what I'm going to do is I'm going to first ask myself, how can I find BK multiplied by AK, right? So it means now I'm going to first focus on the left hand side, right? So what's the left hand side? Let me cover this like that. So the first thing that I'm looking for, it is that BK multiplied by AK. I just want to see that what is this equals to. So to do that, I'm going to go to my ratios, and then I'm going to see where do I see BK and AK. So you can see that I can see a BK there, AK there, BK there, right? And AK there, right? Then I need to pick the one that has a similarity that has BK and AK in the same equation. As you can see here, that this is the one that has BK and AK in the same equation. So what am I going to do there? All right, so here, oh sorry, one thing that I forgot to fix here, it is that CK and KC. These are more like the same thing, right? So let me write it as KC there also. All right, so here, KC, that's fine. So now here, where were we? We were here. So we said that we taken out that ratio. So that's the one that we're gonna be writing. So what am I gonna say here? I'm gonna say KC over AK equals to BK, right, over KC, right? This is the conclusion that we came up with when we calculated that, when we proved that they are similar, right? So this is gonna be prop sides, right, of similar triangles. Okay, so now here, what do we see here? We're gonna cross multiply. So by cross multiplying, I can see that KC times KC gives me KC squared, right? And then here I can see that BK and AK, that's where I get my BK times AK. So what does this mean? So it means here that BK times AK, its value, it is KC squared. All right, so now here, now that I'm done with that one, I'm going to go to the next one. So what is the next one? The next one is to find what is OT squared times CA squared over CT squared equals to, right? So now what I'm going to do is I'm going to use that KC as a guide, right? Not only that, I'll also be checking on my diagram, where do I have what? Where do I have my OT, CA, and CT, right? So now here, we're going to be marking all of those OT, CA. I can see the CA there and CT. I see that there's OT there, CA there, CT there, CT, OT. There we go. Then from here, basically what I want to do is I'm going to look for the one that has all three, right? Because I need all of these three, right? So now here I can see that this is the one that gives me all of them. Just like we did on the BK and AK, we pick the one that gives me both AK and BK. Then here we pick the one that gives me OT, CA, and CT. Now I know it is not squared, but it is that, right? So it means we need to basically use that, right? It has some of those things. So with this one, what are we going to do then? We'll then say KC over OT. This is equals to, let me see there, go back, CA over CT. CA over CT. So here, these are prop sides, right? Or let me just write prop of similar triangles, right? So I can name those triangles if I want to, but it's fine even if I don't, right? Now from here, I can see that I can achieve this OT if I take this OT and multiply there, right? So by doing that, I'm left with KC being equals to OT times CA over CT. Now, how can I make this squared? I can make this squared by squaring everything both sides. So by doing that, I have KC squared being equals to OT squared times CA squared over CT squared. And then by having this, you can then see now I do have the value for what? For OT squared times CA squared over CT squared. It is KC squared. Now notice something. In the previous part, the first part, we said that BK times AK was KC squared, right? And then now we're saying that OT squared times CA squared over CT squared, it is also KC squared. So what does this mean? So it means these things are equal. So therefore, BK times AK is equals to OT squared times CA squared over CT squared. And that is how we get our final answer. And that is how we end this video. I hoped you really enjoyed the video and you learned something. Remember, don't forget to share this with your friend, and also tell me, leave me like anything, just let me know, how did you find this video? Did you like it? Was there something that you would like me to actually help you out and explain furthermore, so that you can basically generate such video?